Hi, in this video, we want to take a look at measures of central tendency. All right, so when I have data and I need to start interpreting it, I need to figure it out. Our measure of central tendency is going to be a one number summary of our data set that tells me where along the number line is my data. That's it. I want to answer the question, where's my data? And I want to do it with one number. That is my measure of central tendency. Now, if you think about it for a moment, if I have 1,000,000 data points or 1,000 or even just 10 data points, and I'm using one number to represent where my data is along the number line, there's going to be some information loss, right? But it's okay because it's just a one number summary. It's a summary of our data, just saying where is it. All right, so this is a fundamental concept in descriptive statistics, and providing a way to describe the typical or central value of my data. In statistical analysis, it is important to summarize data in a way that is meaningful and informative. So this is super important that my measure of central tendency is a summary that is meaningful and informative. Measures of central tendency are statistical tools that help us to understand the general characteristics of a data set and provide a reference point for comparison. All right, so there are three major ways of measuring central tendency: mean, median, and mode. All right, now, one thing I'll actually go a step further. I'll say, you know what? In my opinion, it's actually just two, because mode we don't use too often, and with modern data sets, with larger data at least. All right, so the mean is I add up all the values, divide by the number of values. The arithmetic mean, we learned in elementary school, middle school, something like that. The median, so like the median when you're driving on the road, the median is in the middle of the road. The median of the data set is the middle of the data set. And the mode is the most frequent observation. Now, each of these have advantages and disadvantages. All right, so the mean, this has the most theoretical properties to it. From a theoretical statistics point of view, it's really good for a lot of things, but it's vulnerable to like a few large values throwing off it. It's sensitive to that. So if we're worried about that sensitivity, the median, the middle of the data, is a good choice to use. Now the mode is good for checking to see, like, honestly, I use it primarily to see if there's any oversampling of a particular level of the data. That's where I use it the most professionally at work. Mean and median by far are the most frequent ones to be used professionally. Now, there are other measures of central tendency. And by understanding these measures, researchers and analysts can gain insights into the central tendency of their data sets and draw conclusions about the population that the data represents. Measures of central tendency are a crucial component of statistical analysis and are essential for making informed decisions in a variety of fields. I use measures of central tendency probably every day at work, as a data scientist. All right, so the primary measures of central tendency are the mean, that is the arithmetic mean, add them all up, divide by number of observations. That's what this formula is telling us. It's represented with X bar. The mean is appropriate to use when the data is symmetric and there are no extreme values or outliers that could skew the results. It's most commonly used measure of central tendency and provides a good indication of the central value of a data set. And so the mean is, it is like the benchmark for anything else in terms of central tendency to be measured off of. Now the median, think of middle value. This is the middle value in a set of data where the values are arranged in order from smallest to largest. If there is an even number of values, then the median is the average of the two in the middle. All All right, so it's either the middle value if there's an actual middle value, or it's the middle two if there isn't a true middle value after I sort the data. And so here, the x tilde here is how we denote the median. That is if there is a middle value, that's it. And the subscript indicates its position within the data. And if there isn't a middle value, because we have an even number of observations, then it's the average of the middle two. The median is best used when the data is skewed, such as when it's not normally distributed, or when there's an extreme value or outlier that could affect the mean. The median is less affected by extreme values than the mean and provides a better representation of the typical values in a data set in these cases. So when do we not want to use the median? The median is a worse choice when I only have a few values in there. So imagine all my data is 5 or 6. Or let's change that. Yes, let's say all my data is 5 or 6. Then, you know, unless I have exactly equal representation of 5 and 6, then my median is going to be 5 or my median is going to be 6. Okay, so unless my data is exactly 50-50. All right, so that means that my middle value will be equal to my maximum value or my minimum value. And so that doesn't work out. So if I only have a few distinct values of numbers, the median tends to not be as good of a measurement. Now, the mode is the most frequently occurring value in our data. All right, the mode is useful when the data set has a prominent peak or when the goal is to identify the most common value or category. The mode is not influenced by outliers and can be used with any type of data. Now, we can have like a spike in a value from like errors in measurement and mistakes in recording data, omissions. The thing like the mode can be an indication that there's other problems in our data. So I typically don't use the mode for measures of central tendency. Now, there are other measures of central tendency. Honestly, there's probably like infinitely many you could come up with, but I'm just going to go over some few of the, like, I'll call them the second stringers. So the geometric mean. Okay, so with the arithmetic mean, the mean that we talked about before, we add them up, divide by n. With the geometric mean, we multiply them all up, then take the nth root. So it's like the multiplication version of the mean. It's a geometric mean. And so we take the nth root of the product of all of our data. And the geometric mean is useful when the data consists of ratios or rates, such as growth rates, interest rates, or inflation rates. The geometric mean provides a measure of central tendency that is appropriate for multiplicative changes. All right, so I was working on a project today, and I almost used the geometric mean. I really thought about it. I didn't end up using it. It would have been reasonable, but I went with the arithmetic mean because that is what my audience is more comfortable with. They're more familiar with it. So I decided to use what my audience would be more receptive to. But honestly, if I was talking to a bunch of statisticians, a bunch of mathematicians, I would have used the geometric mean. Now, the harmonic mean, this is another average that's calculated, but it kind of flips things up on its head. So we divide all our data, or we take the reciprocal of all of our data, we add all those reciprocals up, then we divide the number of observations by the sum of the reciprocals. Kind of a crazy formula here. The harmonic mean is useful when the data consists of rates or ratios that are inversely related, such as speed and time. The harmonic mean provides a measure of central tendency that is appropriate for averaging rates or ratios. So if I'm dealing with rates or ratios, I might want to use the harmonic mean. Now, the weighted mean, and this is one that I've used quite a bit, a mean is taken into the mean that takes into account the relative importance of each observation. And so imagine a situation where I want to take an average. I've got a previous value. I have a value that was previous to that, and a value that was previous to that, another one that was previous to that. I have this, this chain of values, and I want to know what the current average is. And so I know like 10 observations ago, that observation is not nearly as important as the most recent one. And so here I want to put a weight so that the one that's closest to now has more weight. The ones that are older, that are newer, or older and that have been around for a while, those have lower weight because I know that they're not as representative of what's happening now. And so what we do, we take our data, we multiply by the weights, then add them up, and then divide by the sum of the weights. And so this is a very good way to go. The weighted mean is useful when the data has different levels of importance or weight. The weighted mean gives more weight to data that is more important or representative of the larger proportion of the data sets. Now, the next one is the trimmed mean. All right, so we use this when we have outliers. So if I have outliers that have extremely large or extremely small value, then either far to the left or far to the right on the number line, I could look at it and go, you know what, I don't think these really represent what's going on. These might be flukes, or this is kind of throwing off what I think the number should be. So what I can do, I can just trim them, get rid of the outliers, and then I pretend that the trimmed data is the data that I actually have for taking my average. And so then I just go through, I drop the values that I drop the most extreme values from my data set for the purpose of this calculation. And then I just take the average just like I would normally, but now my sample size is a little bit smaller. All right, so the trim mean is useful when the data has extreme values or outliers that can distort the result. And the trim mean removes a certain percentage of the highest and lowest values in the data set, providing a more representative measure of central tendency. Now, the next ones to talk about are the mid-range. So the mid-range is the middle point of the largest and smallest values in your data. Typically, I use this one when I'm in a presentation, or I'm watching a presentation, someone shows me their maximum and their minimum values. And to get an idea of what the central tendency is, I just take the average of their max and their min. Easy enough, I can do that, in my head. Quartiles, here we divide the data set into minimum value, first quartile, where 25% of the data is less than that. The median, 50% of the data is less than that. The third quartile, 75% of the data is less than that. And then the maximum value. So we take 5 numbers and we break up the data into approximately 4 equal subintervals. And that gives us an idea of the distribution of our data. Deciles are similar to quartiles, but we break it up into 10 equal parts. And then percentiles, we break it up into 100 approximately equal sized parts. And a vigentile, which I have used at work several times, is where we break it up into 20 approximately equal sized parts. So here are some examples. Let's say that this is my data. When I take the mean, the regular, add them all up and divide by n, I get 27.9. The median is the middle value. So let's see if I can find the middle value here. Oh, it's not sorted. All right, so we have 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, find the smallest 5 values. We got 1, 2, 3, 4. Oh, and this is 4, and that's 5. So 28 is the 5th one, and 29 is the 6th. So these two, even number of observations, these two, 28 and 29, are my middle 2 values. If I was to sort these from smallest to largest, and I can see, I take the average, I get 28.5. Now to get the mode, what I need to do is take the observation that's the most frequent. Now you'll notice that all of them appear equally often on this particular data set. I did this intentionally, by the way, to make sure we see this, that our mode, if I have more than one value that has the maximum frequency, then all the ones that have that maximum frequency are included. So here, every single data point has a frequency of 1. Maximum frequency is 1. Every single data point is a mode. So this is another disadvantage of the mode, is that it's not unique. Now, geometric mean, I'm going to take the product of of my observations. So I'm going to take the multiplication, the product of multiplying them out, and then I take the nth root, and we see we get 27.5. Okay. Now the harmonic mean, I'm going to take all my data, take the reciprocal, add them up, and then I'm going to divide in by the added up reciprocals. And we see we get 27.2 approximately. And then a weighted mean, we have to specify the weights. All right, so when I do this, I just, to make it easy, I said the weights are 1 to 10. So I'm saying that the last observation has 10 times as much importance as the first. I'm saying the second has twice as much importance as the first. The third has 3 times as much importance as the first. What we're going to do, we're going to take this, we're going to multiply each of the values with our observed data, add them up. Then I'm going to divide that sum by the sum of 1 to 10. And we see we get about 28.5. Now the trim mean, I just declare how much I want to trim off from each side of the data set. So here we're trimming off 20% from each side of the data set, and we can see we get 27.9. Each of these measures of central tendency has its own strengths and weaknesses, and the choice of which depends on the nature of the data and the research question at hand. Now, I want to leave you with this. If you don't know, go with the median. And why do I say that? Because if I have skewed data, then I probably don't want to use the mean. I want to use the median. If I have symmetric data, then the mean and the median are going to be pretty close to each other. And using the median will give me about the same thing as mean. So either way, the median is a good choice. So if you don't know, use the median. If you don't feel okay with the median, then go with the mean. But one thing I should say about that, always do what your audience wants. Make sure your stakeholders, your decision makers, are comfortable with whatever course you go. As long as you do that, you'll be good. All right, so here's your homework assignment. Just a bunch of stuff to read over and execute. You can do this by hand with a calculator. Actually, with these numbers, you could do this by hand with just pencil and paper, but I'll leave it to you. All right, so that's all I've got. Life is short. Do math.